So just for the benefit of anybody that wasn't here, is this still 27.2?
Yes.
I think I left those alone. Thank God. All right. Fast Jeff didn't really totally screw me over. So what's going to go in the middle of this picture? What always goes in the middle? The mean, right? So up here, what were we putting in the middle? 0. Why? They're z-scores, and the mean will always become 0, because the mean is 0 away from itself. I like it. And remind me, what is that question I'm going to ask on every test? What's the z-score tell you? I like it. And it's the z-score tells you the number of standard deviations from the mean to the data point. Kick ass. So it is a unit of measure. Standard deviation is instead of inches, and then the z-score is when I take a measurement. Okay, so down here I'm going to put 33.74. And then I want less than 27.2. So I want this area down there. And we did that whole thing about why does it make sense that the area in a picture is exactly equal to the probability. We did all of that, right? So now we're kind of past that. So really at this point it's, how do I get the area? So if it's uniform, thank the gods, I just get an area of a rectangle. I don't need any help. This thing, the hell, I don't have a formula from geometry for the area of curvy triangle dude down there, right? So then I need some help. And that's what the chart does. So how can I tell me two things about this chart? I can only use this chart when? When I have a z-score, but more importantly, sort of, it has to be what kind of distribution? Yeah, a normal curve. I love it. Okay, so, in number 2, do I have a normal curve? Yes, check. Do I have a z-score? No, shit. How do I change this into a z-score? What's the formula? That's how you convert a raw score to a z-score. How many of these fit in this distance? That's what that formula is, which is exactly the definition. Okay, I like it. And we did that. We did our data point minus the middle divided by the spread. And again, this is all about, if you understand the ideas, you will catch silly mistakes quickly. The z-score's got to be positive or negative. I know already it's going to be negative. Before I do any math, it's got to come out negative because it's below the mean. So if you don't get a negative value here, normally that means you turn these around. And what do we get for the z-score? Negative 0.76? Okay. Oh, shit. In case you can't see that, can you? All right. And then if you look up negative, I don't think anybody here hasn't actually used this yet, which is better. If I look up negative 0.76, so the top row tells me the second decimal place. That's how we got 0.2236. Is that cool? And how do I know that's the answer? How do I know to put it where I put it? Yeah, it always tells me the area below. The chart tells you what it tells you. The picture up there. All right. So I put it there, and it happens to match up with what the question was. So if the question was greater than, I would do 1 minus that to get the other side. I love it. I love it. Okay. So let me give you this. I've got a handout. I know, that's crazy, right? One side is very colorful. For me, it is. 2 colors, Jeff. Way to go. Don't worry about that side yet. Side's very freaky. Do this side. This is the practice with z-score stuff. It's all about rents in New Zealand versus San Diego. Rents is appropriately a 4-letter word here. Anybody else? Anybody need to borrow a calculator? You know what to do.